Okay, number one. We're looking at an angle of 120 degrees negative, and that's going to be for the first 5 questions. You're going to be using that same angle, negative 120. First thing it wants you to do is to draw it. And standard position always starts on the x-axis, on the positive side of the x-axis. Negative 120 is going to go downward. Here's negative 90. 30 more would be where negative 120 is. So that would be your angle going in that direction. That's a negative 120. Has to go down. Coterminal angle is number 2. Coterminal angle are angles that are in the same position. Same position angles. And this one is telling you exactly what it has to be between. You have to find a coterminal angle that's between 0 and 360. Got to be between those two. So what I'm going to do to this negative 120 is I'm going to add a circle. I'm going to add a rotation. 360 is one rotation. So if I add these two together, that's going to give me 240 degrees. 240 degrees is between 0 and 360. It is a coterminal angle. Yes. Negative 120 is the angle that we're using for numbers 1 through 5. Okay, so 240, if you notice on the one that we just drew, 240 would be the angle that would go this direction. But both of them stop right there at that place. They're both the exact same angle. One goes downward, one goes up. So there's your two different angles, but they're the same angle, so they're coterminal. Okay, so 240 is between the two numbers that you're looking for. It's helpful when they give you an interval because now you know exactly where to look for your answer. There's technically infinite number of coterminal angles for this angle. I could keep adding 360 and get bigger and bigger and bigger and bigger angles. But they're telling you just want the one between 0 and 360. And there's only one of them in that interval. Now convert the angle to radians. We're staying with the negative 120 for the 1 through 5. Converting it to radians, you would take the negative 120 and multiply it by pi over 180 to make it radians. Changing from degrees to radians, you multiply it by pi over 180. And then you just reduce. I would try to cross cancel. What can you divide 120 and 180 by? 6, 10, they both end in 0, right? So I might start with 10 to get rid of those zeros. And then I would do the 6, and that's going to give me a 2 and a 3. So my answer is negative 2 pi over 3. So negative 2 pi over 3 is your answer to 3 for the radians. That would be how many radians the negative 120 is. It's negative 2 pi over 3 radians. Number 4 is asking for a reference angle. A reference angle is the angle that gets you back up to the x-axis. And it's always a positive angle. Gets you up to the x-axis. So if we're here, remember this right here was from 90 to 120 was actually 30 degrees. So what angle would get me back up to the x-axis? Have to be 60 degrees would be your reference angle. You could basically take 180, subtract the 120, because that's how many degrees it was, not worrying about the negatives, you would end up with a 60-degree reference angle. Yeah. $180 or $360. Yes. Yeah. If it's bigger than 270, you want to subtract it from 360. All right, and the last one is easy as far as the chart goes. If you have your chart, then you'll be able to find all 6 trig functions because you'll know where to look now. What was my coterminal angle? 240. If you didn't write your negatives on here, then you know 240 is the place you want to be looking on your chart. 240, if you read it all the way across, the sine is negative radical 3 over 2. Cosine is negative a half. And the tangent is radical 3. Your cosecant then is negative 2 radical 3 over 3. Secant is negative 2. And the cotangent is radical 3 over 3. That's all on your chart at 240. Why 240? Because that's the same angle as 120. That was my coterminal angle. That was the angle that ended in the same place. So if you did number up the negatives on your chart, negative 240 would have had a negative 120 next to it. Those are the same angle. So that's the angle you're going to want to get on your chart is your coterminal angle. Yeah. Yes, I did. All right, so there's 1 through 5. Now we're done with that negative 120 degrees. That was all for the negative 120. Now let's go down to 6 through 8. Those are all separate problems on their own. 6 says to convert 2.35 radians 2 degrees. So you're going to take the 2.35, multiply it by 180 over pi. The other one was pi over 180. So we went 2 radians, we multiplied it by pi over 180. When you go 2 degrees, you got to flip that around and do 180 over pi. So in your calculator, you'll simply take 2.35 times it by 180 equals, divide it by pi, equals, you get 134.6. 134.6 degrees would be number 6. Now number 7 is asking you the exact same question, but it's giving you a radian measure with a pi in it. So you could do the exact same thing, 7 pi over 3 times 180 over pi. That will still work. You could also have taken out this pi and put in 180, because that's how many degrees pi is. Pi is 180 degrees. Either way, the pi's are going to cancel out. You're going to be doing 7 times 180 and dividing it by 3. Either way you decide to do it. So 7 times 180, and then divide it by 3, and you're going to get 420 degrees. Your answer to 7 is 420. 420. Now look at 8. Number 8, they give you 2 clues, and they want you to find out where the triangle would be located with these 2 clues. So let's look at the 2 clues here. You've got a sign, and I would write right underneath it, I'd write positive because it says greater than 0. That's what it means. It means that the sign is a positive amount. So right on your paper, put down positive underneath this where sign is greater than 0. And under this, I would put negative because tangent's negative. Now, if you draw your x and y axis, you got to find out where the triangle is going to be located in one of these quadrants. Which quadrant has a positive sign, or which 2 quadrants have a positive sign?
1 and 2.
Okay, 1 and 2 is right, because if you remember, at the top of your chart, we should have put the y at the top. The sign represents your y coordinates, and the y coordinates are always positive above the x-axis. So it's got to be either quadrant 1 or 2. Well, what do we know about quadrant 1? Everything's positive there. What do I have? This right here is going to be a negative tangent. So could I be in quadrant 1? No, I can't, because it's got to be a negative tangent. It's got to be in quadrant 2. Now the tangent gives us the opposite side, and it gives us the adjacent side. Oh, a TOA, right? So the opposite is a 4, the adjacent's a 3. So my adjacent's coming over 3, and it's going to be a negative 3. My opposite side is a 4, and I just need to find my hypotenuse. And my angle is always down by the origin there. How do I get my hypotenuse now? A squared, B squared, C squared. You're going to do your Pythagorean theorem. So negative 3 squared plus 4 squared equals C squared. So you get your 16, or your 9. Your 9 plus your 16, and you're going to end up with C is 5. So there is your triangle. Now, all it's asking for in this problem is to find the cosine. Now that you know the triangle, now that you have all 3 sides, you can now find the cosine. What 2 sides does the cosine represent? Cos, C-A-H, adjacent and hypotenuse. Here's your adjacent, negative 3, and your hypotenuse is 5. So your answer to number 8 would be a negative 3/5. Your cosine of that triangle is negative 3/5. So there is 1 through 8. Okay, let me move on to the next couple. 9 through 11. Okay, 9 is nice because they gave you this interval. They told you to, on your chart, and I even wrote it in red here, you can see it. I made a mark at pi over 2, and I made a mark at 3 pi over 2 on my chart. It's telling you your answer is in here somewhere. Has to be between these two. So, because that's what they gave me on my test. It says find the cosine if the cotangent's undefined. Well, look in that area and see if you can find an undefined cotangent. Is there one under cotangent that's undefined? Yeah, I circled it right there. Is that in between those two lines?
Yeah.
Yeah, and then all they want you to do is go back to cosine and find out what the cosine is at that angle. And the cosine is -1. So your answer here is just -1. So your answer, so you look between these two, you found out where the cotangent's undefined, and you came over to find out what the cosine would be at that angle, and that would be a -1. So the cosine is a -1 at that angle. Between the two, it tells you where to look. You have to look between those two. You have to find a cotangent that's undefined, and then you look for the cosine, and it's right there. All right, number 10, find the period, the amplitude, and sketch the graph. So the period is 2 pi divided by whatever's in front of x. What number is in front of x? 1/4. This is a 1/4 right here. It's like a 1 in front of the x, so 1/4. So 2 pi divided by 1/4. How do I divide fractions there? Multiply the 2 pi by the reciprocal, which would be 4 over 1. You're going to get a period of 8 pi. That means on your graph, you should have gone over to the end and put 8 pi. Unless you wanted to do 2 rotations, and then you could have done 16 pi over here if you wanted to. But one rotation would be fine. That's all you're going to see on the test when you look at your 4 graphs is 1 rotation. So 8 pi is this one. Now let's find the amplitude. Amplitude is the absolute value of whatever number is in front of the trig function, which in this case is a 2. So it's the absolute value of 2. That means my graph's going to go up 2, and it's going to go down 2. Up 2 and down 2. Now, we need to decide, it's a sine curve, so what shape is it going to look like? A bow tie. So where does it have to start then? It's got to start at the origin, 0. You've got to have another intercept at the end, and you've got to have another intercept in the middle, which in this case is 4 pi. You've got to have those 3 points. And then between the first two will be a maximum value. And between the last two will be a minimum value, because there's no negatives over there. It's all positives. So there is your bow tie graph right there. And you could do another rotation if you wanted to. It would get you out to 16 pi. You don't have to do that. Just 1 rotation is fine. You need to know the 5 points, and you need to know the correct direction and the correct shape. On the test, you might see some bow ties. You might see some V shapes. You got to know which one to pick. You might see a bow tie that goes up, and you might see one that goes down. You got to know what direction to pick. Okay, so that's number 2, or number 10. Yes. 32. They're multiple choice, so it'll be okay. Tangent graph. What am I going to set this 2x equal to?
Pi over 2.
Pi over 2, because that's where the tangent graph is undefined. If it was a cotangent, you would set it equal to 0 and pi. But with a tangent, you're going to set it equal to pi over 2. Because that's where, on your chart, tangent pi over 2, undefined. So we want to find out where I'm going to put my dotted lines here. So you could divide by 2, or you could multiply by 2 to get rid of the fraction. So you get 4x equals pi, divide by 4, and x is going to be pi over 4. And since it's symmetrical, negative pi over 4 is going to be your other dotted line. So you're going to have a pi over 4. You're going to have a negative pi over 4. Those are going to be the 2 dotted lines. And the tangent curve always has a point on the origin. 0 is always a 0 on your tangent. Always at the top is a 0. The tangent curve, as long as it's a positive, is going to go up on the right side and down on the left side. You're just going to need to know the direction and the dotted lines. If you get those two things right, you'll be able to pick the right graph. There's going to be 4 choices. So you're going to need to know where the dotted lines need to go, which direction it goes in, and you should be able to pick the right graph. All right, there is 10 and 11. Moving on. Why did I put pi over 2? Because that. All right, moving back on. Here we go. Number 12, use a calculator. Now your hint here is the word arc sign. Means what kind of a mode should we be in? Radian mode. So you're going to want to get your calculator and turn to radian mode. You got to remember to put it back in degree mode after this problem's over, because the other problems need degrees. So you're going to go inverse sine 0.75. You're going to get 0.848, which would round to 0.85. Then I would take my calculator and I put it right back in degree mode, so I don't forget, so I have it in degree mode. Because the arc usually stands for radians. This little -1 would normally stand for degree. Normally, unless it gives you the radians like it's going to give you a number 13. Yep. Okay, so now look at 13. It's giving you another interval. It's telling you exactly where to look. Look between pi and 2 pi. So my finger's right here. Pi is 180, 2 pi is 360. We're going to look somewhere at the bottom of my chart, because that's what it's telling me right here. Look at the bottom of your chart. Now, it wants you to find where the tangent is a radical 3 over 3. So go down your tangent column. At the bottom of your chart, where is the tangent a positive radical 3 over 3? 7, 5, or 6 is your answer. You're going to leave radians because it tells you radians. Look and see what it says. If it wouldn't have said anything, I would have probably put degrees because it had the -1. But it tells you radian, so you put radian. So 7, 5, or 6 is your radian angle where the tangent is radical 3 over 3 at the bottom of your chart. Because you had to be between these two numbers. Intervals are nice because it specifically tells you where to look on your chart for the answers. It tells you look between pi and 2 pi and look in there and find your answer. Now we're going to get to the simplifying ones next. Okay, so this right here on number 14, tangent of pi over 2 minus x simply means cotangent. Cotangent times secant. You're going to change cotangent to cosine over sine. And you're going to change secant to 1 over cosine. The cosines will then cancel. You'll be left with 1 over sine, which is cosecant. So your answer to 14 is simply cosecant x. It says don't leave it as a fraction, means don't leave it as 1 over sine. Change it to cosecant. Yeah. Tangent and cotangent would be complements. So yeah, the tangent of one complementary angle is the cotangent of the other. Same with sine and cosine, same with secant and cosecant. So you're going to need to get used to that being a cotangent. All right, 15 is probably tougher than the one you're actually going to get on the test. Because you're definitely going to need to do one with a common denominator. But this one's kind of got a little bit more to it. So what would be a good common denominator here for this one? Cosine times sine minus 1. You just got to multiply them together to get your common denominator. There it is. There's your common denominator. What do I multiply the first fraction by to get this denominator? The sine minus 1, the other denominator. This is going to need FOIL on top. First, outside, inside, and last. You're going to end up with a sine squared minus 2 sines, and then plus 1. And then the second fraction, you're going to multiply by the cosine on top and bottom, the other denominator, so that you'll have a common denominator here. So this is going to be a minus sign next, and then a cosine squared. Now this is where this one gets a little tricky. Because look at the last two numbers on the top, or the last two terms on the top. Do you see this right here? You know that that's an identity? You can take that out and put in sine squared, and now you'll have like terms. So that's exactly what I would do. I would change it to sine squared minus 2 sines plus sine squared again. So I would take this out, and I would put in sine squared in its place. On the bottom, you still have the same two, the cosine and the sine minus 1. Put your like terms together now. Sine squared and sine squared give you 2 sine squareds minus 2 sines over the same denominator. And this next part is very important because on the test, you're going to have to take out a GCF. You have to be able to look at these two and notice that they both have a 2 and they both have a sign. So take out a 2 and take out a sign. And what's left over when you take out a 2 from each one and a sign from each one? You're still going to have one sign from this part. Minus, nothing is left. So what do we have to put here? A 1, because if you distributed it, you'd get back to the 2 times sine. On the bottom, it's going to be cosine times sine minus 1. Do you see what we can cross out now? Sine minus 1s will now cross out. Do you know what sine over cosine actually is? Tangent. So really, your final answer is just 2 tangents. So that would be completely simplified as far as you could to get to 2 tangents. So that was number 15. And like I said, GCFs are going to be important, and that's the same thing on 16. 16, you have a GCF. Uh, 16, your GCF is sine squared. So if I took out a sine squared, what would I have left over? Take out a sine squared from both terms. Cosecant squared minus 1. As you work with the identities a little more, and if you write them on your unit circle so that they're on your paper, you can write them anywhere you want to, as long as you put them on this paper somewhere. This right here, you'll come out as cotangent squared. As you get more familiar with them, you'll notice that this cosecant squared minus 1 would be a cotangent squared. And then you bring down your sine squared. Cotangent squared is cosine squared over sine squared. And you bring down the sine squared. So these will cancel out the sine squared, and all you're going to have left is cosine squared. So your answer to number 16 is just cosine squared. That's all you get. When you put them together, simplify it, you get cosine squared. Yes? This right here, you could have done it a different way. You'll notice you'll get the same answer. This cosecant squared could have been 1 over sine squared. And you've got your sine squareds here, so those would cancel out. So you would have 1 minus sine squared. And what is 1 minus sine squared? Cosine squared. So yeah, that probably would have been a shorter way. But get used to GCFs because you're going to need those down the road. So know the GCFs there. Okay, 17 is verifying that this amount would come out to here. So I'm going to take this, bring it over here. Secant would be 1 over cosine. Cosine is going to stay. I'm going to put a 1 under it. Could I subtract those two fractions? I could if I had a common denominator. I can guarantee you one question on the test is going to ask you what would be a good common denominator for a fraction like that. If you can just tell me what the common denominator is, you're going to get one right. What's a common denominator for those two? Just cosine. you've already got a cosine here. You're going to need to multiply this by cosine over cosine. You're going to get 1 over cosine minus cosine squared over cosine. That's going to give you 1 minus cosine squared on top and a cosine on the bottom. Hopefully you're starting to see what 1 minus cosine squared could be replaced with. What can I put in that place of that? Sine squared is the same as 1 minus cosine squared. Sine squared over cosine. Now we're looking for it to equal sine times tangent. So I'm going to take the two sides and I'm going to break them into two pieces. Sine times sine. On the bottom it's going to be cosine times 1 because that's what cosine would equal. What does sine over cosine equal? Tangent. Sine over 1 is just sine. And that would check. So you'd have your verifying right there. Now, of course, yours is multiple choice. So it might say, like, what would be the first step to verifying this? Or what would be a good common denominator if you're going to verify these, or something like that. So you have to know kind of how to do it so that you can pick the right answer there. Okay, moving on to 18. We want to verify this one. So I'll take this and I'll bring it down in the bottom here. Cosine of x, I'm going to leave it as cosine over 1. Plus sine, I'm going to leave it sine over 1. Tangent, however, I'm going to replace it with sine over cosine. We need to try to make them all sines and cosines if possible. Alright, so we've got tangent we took out and we put in sine over cosine. We're trying to get it to equal secant. So if I bring down my cosine over 1 plus, and I do sine squared over cosine, I need a common denominator once again. If I'm going to put those two together, I need the denominators to be the same. So I'm going to multiply this one by cosine over cosine. So I'm going to get cosine squared over cosine plus sine squared over cosine. Look at that. That's an identity. That's on that little paper. Sine squared plus cosine squared equals 1. So you're just going to have 1 over cosine, which is secant. And it would check. Yes. Let me get to number 19 through 20, 19 through 30. Now, 19 through 21 are one problem. And I always get scared at this one because if you miss the first one, you're going to miss them all. So you need to pick the one that you know how to do first. Now, I'm going to tell you right here on 19 through 21, you've got to use law of sines. You have to because you've got two A's. They gave you two of the same letter, so on the back board is the formulas, and I'll keep it up there. You're going to get the sine of 30 over 9 equals the sine. You've got to do the inverse sine of b because they gave you little b. That's the other piece that you can write down. You've got to use that proportion first. Then it's all calculator work from there. You're going to multiply the sine of 30. Make sure you're back at degree mode because you want to get degree angles here. So you want to get the sine of 30, multiply it by 8, and then divide that by the 9. It's going to give you a decimal, 0.4444. So we want to put in 0.4444 to get angle B. It's going to help us find angle B when we do that. So inverse sine 0.4444 equals, and you get 26.4 for angle B. 26.4 degrees. Now angle C should now be easy for you because you need to make sure they all add up to 180, right? So just take 180, subtract the 30, subtract the 26.4, and I would also double check one thing before you move on. Angle A, or little a, is bigger than little b, right? So what does that tell me about angle A? It's got to be a little bigger than angle B. Is angle A a little bit bigger than angle B? Yeah, so we are on the right track. So we're going to take the 180 minus the 30 minus the 26.4. You get 123.6. And then to get little c, you've got to do one more law of sines. I would use the same one. I'd use the sine of 30 over 9 for this first one, right here. But this time you got to use sine of c, sine of 123.6 over little c so that you can solve for little c. This time you don't have to do any inverses because you have both angles. So you're going to take the sine of 123.6 times it by 9 first. Sine 123.6 multiplied by 9, and then divide that by the sine of 30. And you're going to end up with 14.99, which we could actually round to 15. So little c is going to be 15. So there's the triangle completely solved. You've got all three sides and all three angles. 22 is another triangle that you need to solve. They gave you all three sides. You just have to find all three angles. Since I don't have two of the same letter, I've got to use law of cosine. I used law of sines because I had two A's, so I could use law of sines. This one has to be law of cosines. And my general rule is to pick the biggest angle first. Find the biggest angle. So what I want you to do is use the law of cosines. So I'm going to put c squared, 9 squared, equals 4 squared plus 8 squared minus 2 times 4 times 8 times the inverse cosine for letter C. I'm going to try to find angle C first. And I've got to use an inverse because I want to find the angle this time. This is the formula that's on the backboard for law of cosines. This was the c squared equals a squared plus b squared minus 2 times a times b times cosine of c. The angle has to be what the number in front represents. So if we've got little c in front, then we've got to be looking for angle c back here. Now if we multiply these, that's 81, you get 16, you get 64, you get another 64 there, but this 64 is being multiplied by the cosine -1 for c. These two together give you 80, so if you subtract 80 on both sides, you get 1 equals -64 times cosine -1 for c, divide by -64. So you're actually going to get a 1 divided by 64, you're going to get a 0 point, or negative actually, negative 0.0156. Because it was 1 divided by -64. Then you're going to put that into your inverse cosine. So that goes into the cosine -1. We're going to put that in. So inverse cosine of 0.0156. Oh, I forgot the negative. Can't forget the negative. You've got to put negative in. 0.0156 equals. You get 90.9 degrees. So little c for number 20, or big C here, is 90.9 degrees. That's the hardest one. Because now you can use the law of sines, because you've got both C's now. You have a big C and you have a little c. So I could set up the sine of 90.9 over the little c of 9 equals, and let's pick letter A this time, sine of inverse sine of A over little a, which is 4. Multiply and divide, so I'm going to do the sine of 90.9 times sine of 90.9 times 4 equals, and I'm going to divide that by the 9. And you're going to get the same thing we had before. is 0.4444 again, which we had right up here. So you're going to get the same angle, 26.4 degrees for A. To get letter B, you just do 180 minus 90.9 minus 26.4. 180 minus 90.9 minus 26.4, 62.7 degrees. So that would be B. So that'll give you all three angles. Yep. It's all multiple choice, so you got to pick the right answer. So you won't have to get docked or anything. And you'll be fine. Just with the multiple choice there, you should be fine. All right, so let's go to the area one, 25 and 26. If you remember this formula, and I would write it somewhere right now on your unit circle, so that you have this formula for area. Area equals 1/2 little a, little b, and the sine of angle C. And you're multiplying all those together. You're doing 1/2 times little a times little b times the sine of C. If we go back up to this first problem right here, which I'm going to need to lower it so we can see the little a, the little b's. Okay, so here's little a is 9, little b was 8. So it's going to be 1/2 times 9 times 8 times the sine. Angle C here was 123.6. So I'm just going to put all that into my calculator, just like it is. 1/2 would be 0.5 times 9 times 8 times the sine, 123.6, and you get a area of, which would be 29.99. So that would round to 30. So for number 25, your answer would be 30 square units. 30 square units, because you just plugged it into the formula. That's all you had to do. Just find the formula, plug it in. When you get to the second one, they gave you A, they gave you B, 4 and 8. So it's going to be 1/2 times 4 times 8 times the sine of letter C was 90.9. So you're just going to plug that one into your calculator. So it's 0.5 times 4 times 8 times the sine of 90.9. And you get a 15.99, which would round to 16. So your area for 25 was 30. Your area for 26 was 16. Yes? You're going to need that one formula for 3 problems. Well, it might not be 3 on the test, but it's 3 on here. It's going to be at least 2, because number 29 also needs that formula. So I'll go to 29, 1/2 times little a times little b times the sine of C again. They gave you little a, they gave you little b, and they gave you angle C. So it's 1/2 times 7 times 12 times the sine of 60. And you just plug that all into your calculator, just as is, 0.5 times 7 times 12 times the sine of 60. And you get a 36.37, which we'll call 36.4 square inches. So there's 29. So you get that formula, that's going to cover 3 of those. So if you can write this formula down and have it on your unit circle, it'll help you with at least 2 or 3 problems. 1/2 times little a times little b times the sine of angle C. All right, these 2 we did in our notes yesterday. 27, you're looking for a GCF. You take out a cosine. You're left with 2 cosine minus 1. So that means cosine could be 0, or 2 cosine x minus 1 could be 0. When you solve this, you actually get cosine equals 1/2. So where is the cosine of 0 and where is the cosine of 1/2? That's what we got to look for on our chart, and it just tells us, notice this right here, interval. It gives us the interval. So it says just look on the chart. You don't need to add the 2n pi's like we did yesterday. Just find them on your chart. So if we look at the first one, cosine is 0 at pi over 2, so that's one of our answers, pi over 2. It's also 0 at 3 pi over 2, that's another answer. Where is the cosine of positive 1/2 now? That would be at pi over 3 and 5 pi over 3. So you have these four answers right here. That would be number 27, would be those four solutions. The last one is, or last one as far as the solving go, 28. Let's bring this one down here. You're going to get 3 tangents minus cotangent would be 1 over tangent equals 0. I'm going to multiply everything by tangent because I don't want a fraction. So the tangents will cross out. You'll get 3 tangent squared minus 1 equals 0. Because the tangents canceled out, left you with a 1. These two tangents multiplied and gave you tangent squared. Now that one was actually the exact problem on your notes yesterday. You added 1 to both sides. So you got 3 tangent squareds equals 1. You divided by 3. So you got tangent squared equals 1/3. You square rooted everything. You ended up with tangent is plus or minus radical 3 over 3. So you had to look on your chart and find out where the tangent was a positive radical 3 over 3 or a negative radical 3 over 3. And we found out that it was pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. It was those four solutions. So that was 28. I already did 29, and 30 is just on your chart. Where is the cosine going to be a 0 in your shaded area that you shaded in before? Where is the cosine a 0? At 90 degrees, but they are arc cosine, so we're going to use the pi over 2. So this right here would be pi over 2. We're going to use radians because they gave me arc cosine, so the general would be use radians there. And you'd want to find it in your top part, your shaded area. That's when you're using the arc. All right, there it is.